Hey everyone, I'm Neil. If you're learning chemistry and struggling with polyatomic ions, I think you found the perfect video. In today's edition, we're going to be taking a look at what polyatomic ions are. Furthermore, we're going to investigate how do we actually write ionic formulas incorporating these in a correct way. Thank you so much for joining. If you have a minute and could like the video and subscribe to the channel, that would be greatly appreciated. Okay, let's get started. Okay, so step one of understanding all you need to know about polyatomic ions is asking yourself, what is a polyatomic ion? And luckily the name holds that answer. You see, most ions are single atoms like potassium or chlorine that have an electrical charge. But the name polyatomic ions tells us something crucial. Poly means many, and atomic means atoms. So we're not talking about single atoms with a charge here. Instead, we're talking about many atoms that are ions. In other words, groups of many atoms clustered together with either a positive or negative charge, like this nitrate polyatomic ion right there. Okay, let's look a little bit deeper at a couple examples. Okay, so for our first example of a polyatomic ion, we're going to look at nitrate. You can see its name here along with its chemical formula. 1 nitrogen, 3 oxygens, and a negative charge. So this is a perfect example of a polyatomic ion. Let's think about how it actually forms and what it is. You see, the 1 N in the formula tells us that there is 1 nitrogen atom in this polyatomic ion. The 3 next to the O tells us that there's 1, 2, 3 oxygen atoms that are bonded to that nitrogen. So let's think about this more carefully. We've got a bunch of non-metal atoms here, nitrogen and oxygens. Because they're nonmetals, when they bond with each other, they're able to share valence electrons. So they're sharing them covalently. And therefore, this is a covalent compound. But what makes polyatomic ions unique is that the compound isn't neutral. It's an ion, right? So collectively, these 4 atoms have a negative charge. So again, we've got 1 nitrogen, 3 oxygens, sharing valence electrons covalently bonded to each other, and they have an extra electron which gives them a negative charge. Now this is really important because, as we know, opposites attract. So let's think of a potential scenario where nitrate could interact with something else. For example, if nitrate was nearby a potassium atom, and this potassium atom had a positive 1 charge because it lost its valence electron, this negative charge and this positive charge would be attracted to each other, and we would get the formation of an ionic compound, where of course the charges would go away. So this would be an ionic bond between potassium and the nitrate. But don't forget, the nitrate itself, the polyatomic ion itself, is a group of atoms, nonmetals, covalently bonded to one another. Now, polyatomic ions can be positively charged as well. Let's take a look at one of those next. All right, so next up, we're going to take a look at a positively charged polyatomic ion. And here we have one of the most well-known polyatomic ions, ammonium. Now, ammonium has the formula NH4 with a positive 1 charge. So what is it exactly? Well, we have a single nitrogen atom, as you can see here. Now, we also see a subscript of 4, which tells us that there are multiple hydrogens bonded to this nitrogen. 1, 2, 3, and 4. So we've got a nitrogen covalently bonded to 4 hydrogens. And of course, it's not a neutral compound, it's an ion, so it has a charge. These 5 atoms collectively are short 1 electron, which makes them positively charged as a whole. Now, as we saw with our nitrate example, polyatomic ions are well known for forming ionic bonds with other things that have opposite charges. So for example, if ammonium happens to find itself near chlorine, and that chlorine steals an electron and has a negative charge, we're going to get an ionic bond between this polyatomic ion and this nonmetal. We would make ammonium chloride. In our next segment, we're going to go deeper into how to actually write correct chemical formulas when interactions like this happen. Let's take a look at a specific ionic compound involving a polyatomic ion and how to write a correct formula. Behind me, you'll see the name titanium nitrate and the formula TiNO3 in parentheses with a 2 after it. Let's take a closer look at this formula and ask ourselves, why are the parentheses necessary? Now, we'll start off with the titanium. Titanium is a well-known transition metal, and like most transition metals, it has 2 valence electrons, which it quite readily gives away, forming an ion with a positive 2 charge. Now, of course, it's going to be attracted to anything with a negative charge, so if there happens to be a nitrate nearby, 1 nitrogen covalently bonded to 3 oxygens, with a negative charge, these 2 things will form an ionic bond. But remember, ionic bonds and ionic compounds, they're neutral. They don't have any charge. So if titanium has a positive 2, but a nitrate only has a -1, and they combine, we're not going to get rid of all the charges. This is why we would need a second nitrate to come along and join in on this ionic compound. You see, each one of these has a -1, which combined makes -2. And that -2 would completely cancel out with the positive 2 of titanium. So when this ionic compound forms, the ratio is 1 titanium bonded to 2 nitrates. So this is why we have the parentheses in this particular formula. You see, the parentheses tell us that nitrate, NO3, is a unit. And there's not one of those, but there's 2 of those. So the 2 is representing the fact that there's 2 of these, the formula inside the parentheses, attracted to just 1 single titanium ion. Okay, let's look at some other examples and give you guys some practice.
Most ions we deal with are single atoms with a charge, like sodium with a +1 charge, or chlorine with a -1 charge, but polyatomic ions are groups of atoms that have a charge. Now, these polyatomic ions are held together by covalent bonds, but they can connect with other ions by way of ionic bonding. Some polyatomic ions can be positively charged, others are negative. How are we going to keep track of which ones have which charge? Well, most teachers are going to ask you to memorize specific polyatomic ion formulas and names. Okay, a quick tip before we get into the practice problems. Remember that when you're writing a formula for an ionic compound that contains one of these polyatomic ions, always use parentheses around the formula of the polyatomic ion if there's more than one of them present. Practice question 1. Write the chemical formula for ammonium oxide. Pause the video here and try it out for yourself, then come back for the solution. We begin with NH4 with a +1 charge. That's ammonium, and we will have committed that to memory unless our teacher is going to provide us with that formula on an exam. Oxygen always gains 2 electrons, and so it has a -2 charge. Now, the standard way of writing an ionic formula is using the crisscross method. We take the charges and bring them down without the positive and negative sign, and that's going to tell us how many of each ion we need. In this case, we need 2 ammoniums for every 1 oxygen. Please notice how I use the parentheses. That separates the 4 and the 2 so as to not read 42. Also notice that there's no 1 after the oxygen. In chemistry, it's quite common to not write the number 1. Okay, practice question 2. Write the chemical formula for calcium phosphate. Pause the video and come back for the answer. So here we're beginning with calcium, which has a +2 charge due to the fact that it always loses its 2 valence electrons. We've memorized the chemical formula for phosphate. It's P with 4 oxygens and an overall -3 charge. Now again, we can crisscross those charges, and that's going to give us an indication of how many of each ion we're going to need in the formula. It turns out we need 3 calciums, and we need 2 of the phosphate ion. Again, I've added the parentheses to separate the 4 from the 2 so as to have it not read 42. Well, I'm sure you guys did great with these questions, and I appreciate you watching the video. Please check out my Instagram account for updates on videos, and thanks so much for joining me.